In this video, we're going to be looking at solving quadratic equations with complex roots. So in this question here, we have to solve the equation z squared plus 6z plus 25 equal to 0, expressing your answer in the form a plus bi. Now this question looks the exact same as a regular quadratic equation, except as x being our variable, we have z as our variable. So I'm going to use the quadratic formula, which is minus b plus or minus b squared minus 4ac, all divided by 2a. And we're going to have a is equal to 1, because that's the coefficient of z squared. B is equal to 6, the coefficient of z. And c then is equal to 25. So putting these values in now, I'll have minus 6 plus or minus 6 squared minus 4 times 1 times 25. All over now 2 times 1. So then let's put the square root part into the calculator. Okay, and that will get us square root of minus 64. Don't make the mistake of putting square root and then everything else into it, because your calculator will show an error message for that. So I just put 6 squared minus 4 times 1 times 25 into the calculator, and that gets minus 64. Now, I still have minus 6 now, plus or minus, then all over 2. Now, the square root of negative 64 would be 8i. We covered that in the first lesson on complex numbers. Now we still have the minus 6 plus or minus, now all over 2. So this will simplify to minus 3 plus or minus 4i. So there are two answers, minus 3 plus 4i and minus 3 minus 4i. You'll always see that complex roots are always the conjugate of each other. So you can see the conjugate of minus 3 plus 4i is minus 3 minus 4i. Okay, let's have a look at another one. Okay, so again here, so we have z squared plus 6z plus 10 equal to 0. So again, I'm going to write down the quadratic formula. So a is going to be equal to 1, b is going to be equal to 6, and now c is going to be equal to 10. So let's put these values in now. So we'll have minus 6 plus or minus 6 squared minus 4 times 1 times 10 all over 2 times 1. Now, just put the 6 squared minus 4 and bracket 1 bracket 10 into your calculator, and that gives minus 4. So we still have the minus 6 plus or minus all over 2. Now the square root of negative 4, that gives us 2i, because the square root of 4 is 2 and it's a negative, so it'll be 2i. So minus 6 then plus or minus and all over 2. So divide by 2 now, so we'll have minus 3 plus or minus I. So our roots then are minus 3 plus I, and then minus 3 minus I. Again, you can see that they are the conjugate of each other, so a conjugate pair. Okay, so with roots of quadratics with complex numbers, you can see some other types of questions as well. One of these questions, it looks like this. So we need to show that 6 plus I is a root of the equation z squared minus 12z plus 37, and write down the other root. So the last part, the other root, that'll be the conjugate of this root, so that'll just be 6 minus I. So that's that part done. Remember, roots are always in conjugate pairs. Okay, now to show that 6 plus I is a root of z squared minus 12z plus 37, all you have to do is substitute in 6 plus I instead of z. So I'm going to have 6 plus I all squared minus 12 times 6 plus I plus 37. Okay, so I'm going to expand this first. So that would be 6 plus I times 6 plus I. So 6 times 6 plus I times 6 plus I. So then I have 36 plus 6I plus 6I plus I squared. Now remember I squared, that is equal to minus 1. So now I have 36 plus 12I minus 1, which would be 35 plus 12I. Okay, next bit now, I have minus 12 times 6 plus I. So minus 12 times 6, that would be minus 72 minus 12I. And then I also have a plus 37. Now looking at this, I can see that plus 12I and the minus 12I will cancel out. And if I do 35 minus 72 plus 37, that's equal to 0. And that shows that 6 plus I is a root of the equation. So if you ever have to show that something is a root of an equation, substitute it into your equation and you should end up with 0. One last one. So we're told here that 3 plus I is a root of the equation z squared minus 6z plus k. Find the value of k and write down the other root in the form a plus bi. Okay, so again, let's write down the other root. So that will be 3 minus I, because again, conjugate pairs. Okay, so then we're told that 3 plus I is a root. So then, like the previous question, let's substitute that in instead of z. So we'll have 3 plus I squared minus 6 times 3 plus I plus k equal to 0. Okay, let's expand this. 3 plus I times 3 plus I. So 3 times 3 plus I times 3 plus I. So 3 times 3 is 9. 3 times I is 3I. Then I times 3 is 3I plus I squared. Be careful of the I squared. Remember that is minus 1. That's alright. Minus 1. Okay, so then I have 9 plus 6I minus 1. Let's expand this. So then minus 6 times 3 will be minus 18 minus 6I plus k now equal to 0. So the 6I and the minus 6I will cancel. Now 9 minus 1 minus 18 is equal to minus 10. And then I still have the plus k. So I have minus 10 plus k equal to 0. Bring the minus 10 to the other side. So that means k is equal to 10. And that's the value of k. Okay, so any questions about that, please leave in the comments. Thank you.